Good morning. I'm going to start right away. My name is Cédric Brun. I'm a member of the modeling PMC. I'm involved in many Eclipse modeling projects, mostly modeling projects. And well, I often have questions, either in real life or through Bugzillas or the Eclipse forums, about Eclipse modeling in general and about understanding what this project is about, because that's a project which contains many sub-projects and components. It tackles many areas in modeling. So it's often hard for users to understand how they can use Eclipse modeling projects, what kind of benefits they can get from it. So I'm trying to, with this talk, to give you a brief overview of the Eclipse modeling project and how it could be useful to you. So we'll just follow the white rabbit through the Eclipse modeling project and see how it goes. The main points you should get when you leave this room is the Eclipse modeling project is a rich and diverse ecosystem. It's made from several kind of teams with different kind of agendas or objectives. And it provides mature technologies and framework you can use either to build applications directly or to build dedicated tools to help you build your application. And at the end, we are going to, well, I'm going to show with a quite small example how you could use the Eclipse modeling to set up your own tool very quickly. It's a matter of hours to speed up your software development. So what is modeling itself? I think that's quite a simple definition. Modeling has been here for decades. If you want to build a system, if you need to design a system, you need to be able to test some of its properties. You need to be able to structure your system, to document it. And that's what modeling is about, right? It's just about capturing information to represent a system so that you can validate, prototype the system, and simulate it, see how it goes, if it fits the requirements. Maybe automate the creation of either the complete system or part of it, and document it. So it's not provocative definition. Mainly capturing information in a way that you can leverage it. Which brings me to what makes a good model. A good model is a model which allows you to answer a question. It has a purpose. If you have a model and you're not even able to see what kind of question it's answering, then it's just drawing stuff, but it's really not something you should do. And the more important point is a good model is a model which is used. It's used either to generate stuff, it's used to document stuff, but if you're not using the model, then just don't do it. So that's the two metrics I'm using to decide whether a model is worth it or not. Let's get back to the Eclipse modeling project. So, as you may have guessed already, it's an Eclipse project. In fact, technically it's a top-level project. So there are a few top-level projects like technologies, Mylene for ALM, for instance. So that's a project which contains several other projects. In itself, Eclipse modeling is not doing anything. It's just a container. But this container is composed of a very diverse kind of team. A lot of Eclipse projects are initiated by some kind of team. I would say, for instance, a company which is a tool vendor, or a company which is a service provider, or individuals, for instance. Here in the Eclipse Modeling project, all the sub-projects are from different horizons. Well, some of them are done by software service provider, other by tool vendors, sometimes a mix of both. Some of them are done by academics, some of them by individuals which are doing consulting. That's something you should really have a look on, because depending on who is doing the project and what are their objectives, obviously the objectives of service provider will not be the same as a tool vendor or as an academic. So you really need to have a look on this so that you don't have surprise regarding your expectation of what the project is going to provide. And it's also a project which has a wide range of audience. Some components might be used for a lot of different things. We'll see that just later on. A wide range of maturity level. Some components have been here for quite a long time, like maybe 5, 6 years or more, or pretty much since the beginning of Eclipse. They've been used a lot and they're very mature. Other components has just got created, so they don't have the same level of maturity, but they might be useful anyway, but you really want to check that. So we have the incubation status on projects which are not providing, which are not committed to keep, for instance, API compatibility, are in the incubation status. Project which just got created are in the incubation status. It's fine using a project which is in incubation status. You just want to know that. And sometimes you might want to know if anybody else used this project. That's something really hard to know when you're just browsing the website. But if you just ask the project committers or project leaders, well, they will be able to give you references most of the time. So that's worth trying. Our main issue, I would say, in the Eclipse Modeling project is that we have the most amazing collection of acronyms, and more especially 3-letter acronyms. That's making things very hard for the end users. That's just a glimpse. I'm pretty sure some projects are missing here. So I'm going to, well, lead you through this jungle, hopefully. So here's the basic project structure. So we have several container projects inside the Eclipse Modeling project. So as I said before, we do like 3-letter acronyms. It just started like that, so anybody which would want to propose a new project at Eclipse was maybe thinking it was, they had no choice than choosing a 3-letter acronym. But in fact, we have model management, which is the focus of the EMF project. Model management involves designing models and, well, sharing models, comparing models, all that stuff are in the model management part, which is EMF. We also have part of the Eclipse Modeling project, which is dedicated to standards mostly, which is MDT. Well, I would say at the exception of Sphinx project, which is in MDT, if I recall correctly. Text generation, it's M2T for model to text. Well, graphical editing with the GMP project, textual editing with the EMF project, model-to-model transformation with the MMT project, and the agent-based simulation project, which is kind of specific, but a pretty cool project anyway. And two other projects which are quite special. The EMFT1, which is an incubator. If I'll switch back. The EMFT1 was the incubator for the model management technologies. I just said was because now we're creating the project at their right place from the beginning and just use the incubation status. But it used to be that some projects were created in EMFT, and when they get out of the incubation status, they graduate and move to EMF. And another one, which I'm the leader of, is the amalgamation project. It's focused on packaging the Eclipse modeling components. Every year we deliver, just like Jan said before, for the release train. Most of the Eclipse modeling projects are part of the release train. So we delivered since, well, Galileo, Helios, Indigo, and Juno. And what is the single stop to discover Eclipse modeling technologies? It's the Eclipse modeling package. It includes a fairly small set of technologies already installed, and it also provides a way to discover the other technologies and to quickly install them with just one click, and you're able to install all the other technologies. That way the package is not bloated with everything. It's just a pretty small subset, and you can easily discover things you might not know it exists. Let's get back to the subject. Why would Eclipse modeling be worth it for you? Well, two things. Either you want to build an application directly using Eclipse modeling, and some of the technologies are quite good at that. And then we'll see later on that you could even build tools. So you can use EMF core as is, which means you can design your domain model using, for instance, a graphical modeler, which is packaged in the Eclipse modeling package. You initialize an EMF generator model, and then it generates the corresponding Java code. The corresponding Java code is fairly straightforward. It's pretty much has the API you would expect from your model. And what do you get from this generated code? Well, you have a domain model. You can instantiate instances of the domain model. You can serialize them using XMI, XML, or binary formats, for instance. You have a Java API to manipulate your model. Every model element might be referenced using URIs and fragments. You can listen to anything, any change in the model, either reacting to each change or reacting to a batch of change. You have a REST-like API for documents. You have also a reflective API so that you can write code which manipulate the model, even if it doesn't know how the model is structured at first. You have commands which are set up for you. You have free undo and redo in editors and so on. So that's just the EMF core, which is providing you that from your model you just designed. But there is a cost, right? It comes with a runtime, the EMF runtime. It's not big in a sense that big would mean now. It's standalone, which means you can even write classical Java application with it, but still it's a dependency you add when doing that. Most of the time you'll need UI for your application. So you either using EMF itself, which generates very basic UI, or using the EEF project, to generate richer applications. You could also generate web application from your domain model. EMF generates either a wrap application, which is some kind of, well, which is Eclipse RCP, but in a browser, or even GWT application from your domain model. So you get a model editor generated, which is working directly in GWT. And if you add to the mix a model repository, like for instance the CDO project, then you can start building distributed and connected applications with different kind of concurrent strategies, offline support, lazy loading, and especially lazy unloading, which means if you don't use the object, it's just going to get garbage collected. It's using database backends and so on. So that's pretty cool, and it allows you to build connected applications like this one, which is some application to order dishes in a restaurant. So some customer order a dish, and the order is updated everywhere. The model gets just updated everywhere lively. So it's very nice technologies if you want to use the Java stack, probably the Eclipse RCP stack, maybe wrap. But if you want to get out of this kind of stack, it's just, well, it's just not for you, because the choices which are made in the generated code will not be a very good fit for you. So it's not enough for any app. I'm not saying you should use it for any kind of application. But it brings me to the other side of Eclipse Modeling, which is more interesting, which is to build dedicated tools. You can build graphical modelers for your models. GMF has been there quite a long time already. Graffiti project, which got created a few years ago, is kind of the new challenger in town. Using Xtext, you can build even complete IDE for your model with your own syntax and compiler and validation, completion, and so on. Form-based editors are coming pretty much for free also using the EEF project. And you can, well, generate text from your model using, for instance, the Acceleo project, which is a template-based generator with a complete editing and debugging environment. The runtime is standalone. You can generate iteratively, and it's based on OMG standard. So you can define the way you want to capture information, define your model, and from that derive a complete modeling environment. So you can, all the PCs are here to build a full-blown environment with large-scale deployment and distribution, rich modeling tools, graphical, textual, forms, and so on. Fine-grained collaborative supports, the ability to customize the tools and share this customization, to support huge models, to have code generator which might be customized by some teams, for instance, and all the tests for all this tooling. Obviously, that's kind of awesome. If you're building something which is very expensive and which you don't want to screw up, it might be worth it, but it might be costly too. On the other hand, on the other extreme hand, you can build a tooling very quickly, just using the reflective editor. So that's not going to work if you want the business people to edit the model, but if you have developers, it's just fine. Doing so, you can deploy your tooling just using USCM. It might be SVN or Git or whatever. Just have a project which contains your tooling. You can use EMF compare to collaborate on the model so that you're able to diff and merge. And you can automate code generation, automate the generation, for instance, of part of your application. Obviously, there is no strong rule, so you have the cheapest tooling which you can set up in a few hours, the more costly tooling which will need, well, months of work, and most of the time the truth is, well, behind, well, not behind, but in the middle, probably. So let's try quickly. If you want to do this yourself, you'll need Eclipse, EMF, and Acceleo. And we're going to, well, I'm going to show you how to build a model to keep track of your app features among versions. All that stuff, you can install it in 2 clicks using the Eclipse Marketplace. So is that model a good model? Well, it's answering questions. What features have been updated, created in version 1 dot something. And we're going to use it to generate skeleton of tests, UI tests or acceptance tests, and to generate end-user documentation so that the end-user see what did change among versions. How do we proceed? We first start by coding a prototype of what you expect. I would not advise you to start doing the tooling. Just start by doing the kind of results you expect. Then create the domain model, an instance of this domain model, a generation template to generate the tests and the doc, and then launch it. So here is the prototype of what I want to get. So I just created a small HTML page using Twitter Bootstrap because that's what the cool kids do now. And some, well, very crude test case for some feature. So I have the code of what I want. And now I'm able to see what kind of information I want to capture, because as I created the example of what I want to get, it's way easier to see what I want to capture. So a product which might have features, which might be updated, a feature having a version, which might have, well, several updates, and so on. It's a very simple domain model. And right-clicking on this domain model and saying to EMF, I want to create a dynamic instance, I can create an instance of this model. So the tooling is pretty crude. It's just the reflective editor, but I can set the values and share this data using SVN, for instance. So here I created an instance of this model for the Acceleo project with several versions, several features, updates, and so on. And from this, I can create a generation template, just copy-pasting the prototype I did at first, and replacing parts of it into a dynamic evaluation like this. So it's very quick to initialize and to set up. Just copy-paste and replace the stuff which needs to be replaced. Launch it. Just create a launch configuration, pick the model, pick the template, and here's the result. So what do I get now? Well, the result might be customized. I don't want to put everything on the model. So I can add stuff into the generated HTML, like for instance, I want to add a screenshot of this feature. I can add it, generate again, do some change, generate again, and what I did add is not going to be lost. So what do I get now? I have a project, one more project in my Eclipse workspace, which contains the whole tooling. You don't have to install the tooling on every developer desktop. You just have to share the project. And every developer is then able to update the tooling itself if he wants to. I have the domain model and, well, just the prototype. So at the left, my tooling. At the right, my usage of the tooling for the Acceleo project with the instance, the generated doc, and the generated test. if you want to have a look, the whole thing is hosted on GitHub. So now I have a consistent vision of our features among versions. I can produce a deliverable which is useful to our end users. And I don't have to care that much about the tooling. So that's a very low cost end of building your own tooling for your own needs. In a nutshell, again, Eclipse modeling is fairly rich. You just had a glimpse of it, so you should probably have a deeper look. If you want to discuss about it, I would be very happy to see you afterward. You can build either applications if you're okay with the Eclipse stack, or you can build your own tools to support your development for your own stack or stack you choose. And you can try it at a very low cost, so why not? Here are a few references. Well, as I said earlier, just catch me and let's discuss if you have anything. Is there any question? Yeah.
So the question is, we have some good experiences with the expand language. Now you're presenting Acceleo. Can you give me some reasons why to change or what's better there?
Expand and Acceleo are very similar in principle. They are both template-based languages. They are both using OCL-like syntax. Well, I'm a committer in the Acceleo project, but I'll try to be fair anyway. I would say the Acceleo tooling is way more advanced than the Expand one. The editors, you have refactoring for your templates, debugger profiling for your templates, and so on. And I would also say that, well, the Acceleo syntax is based on an OMG standard, which Expand is not, but, well, I mean, it's really up to you then to pick the standard or not. And, well, I'm not sure Expand is, I'm not sure the Expand team has a very big plan for Expand now, that they're pretty much more focused on Extend, I guess. But that's something, well, you should probably ask them on the forum, just like I said at the beginning. You should not be shy to ask things. Is that okay? Another question? Or?
Another question, I see the generated code, and it has no test code, or I could expect more generated test code. For example, if an attribute, I can call a set with an empty string, and then I call again to check whether it's empty. So just trivial things for generating test code, which somehow show that the code is running, or you need to have high coverage or so on. Is there some plan or support for this?
Well, EMF itself generates lots of test code which are doing the kind of thing you describe, like making sure set getters are working. But in fact, it's not very useful tests because you don't really, well, change that most of the time. Here in the example I show you, we're generating a test for a feature which we have in our versions model. We could have generated more setup code to test the features, for instance, using SWT bot or stuff like that. But I really did not push the test example, but it's really just a matter of updating the template and generating the code you want. If you want to test generating more code from the test, you'll end up probably adding more information in the model. So you have to make a choice at some point, because if you put too much information in the model, it's just not worth it most of the time. So there's a trade-off to make here. In between the time you need to update the model and design stuff in the model and the time you would have needed to do the same thing using the Eclipse GDT, for instance. But yeah, the example here was very, very simple and should probably be extended. Thank you for your attention, and well, see you later.